All right, guys, here's my next video. This is for Module 5, Problem 3, Part A. This is what yours looks like, right? You have a picture of a cone, a cylinder, and a sphere. And it says on Part A, determine the volume of each three-dimensional figure shown below. Part B, it says you want to fill the cylinder shown below with water. All you have is a container shaped like a cone with a radius of 3 inches and a height of 5 inches. You can use this cone-shaped container to take water from a faucet and fill the cylinder. How many cones will it take to fill the cylinder? And then question C for number 3 says you have a cylinder with a diameter of 15 inches and a height of 12 inches. What's the volume of the largest sphere that will fit inside of it? All right, so I'm going to do a sample problem real similar to Part A, and I'm going to show you how to find the volume of a cone and a cylinder and a sphere. All right, so here's my sample problem, right? You see I drew a cone here, a cylinder, and I'll show you my sphere in a minute. Okay, so to find the volume of your cone, all right, you want to use the formula where it says capital V stands for volume equals capital B times H, all that's divided by 3. Or it's the same as saying volume equals 1/3 base times height. I prefer to divide it by 3 at the end, but you can use the fraction 1/3 at the beginning if you want to. Now the base refers to the base of the figure, and the base of the figure is a circle. So for the capital B, the formula for the area of the circle is pi r squared. That's where I got that from. I just recopied the h here and recopied the 3. So my figure, my radius here, radius goes from the center of the circle to the outside edge, and my radius is 7. So I'm going to take that 7 and sub it in for the r. Okay, you see that there? And then my height on my cone here is this 12. So I'm going to take the 12 and sub that in for the h. And you see that right here. Now you're going to want to use order of operations when you evaluate this. So you're going to have to use PEMDAS, or please excuse my dear Aunt Sally. And so that means we're looking for parentheses, and technically there are none, but we now look for exponents. I put the 7 inside this parentheses so you could see it a little bit better. It's squared. So that means 7 times 7, which is how I get the 49 here. I recopy the pi and recopy the 12. Now, you should have a pi key on your calculator. So now you can just go pi times the 49 times the 12. After you get that, and I have it as approximately 1,847.26, and then you're going to divide it by 3, and my final answer is approximately the volume of my sphere is 615.75 cubic inches. Now, if you don't have the pi key, just use the 3.14 as the representation for a numeric value for pi, okay? All right, now I'm going to show you a cylinder problem. So here's my sample cylinder. My radius is 5. The height of my cylinder is 8.6. The formula is just volume of a cylinder is capital B times H. And again, the capital B is the area of the base, and the base is a circle. So I'm going to replace the B with the formula, the area formula for a circle, which is pi r squared, and just bring the H along. So now I'm going to sub a number in for my r. In my example, the radius is 5. Now your radius is different, so you would sub a different number in, but you're going to use the same formula, right? So just use mine as a model. So now I have pi times 5 squared. My height was the 8.6, so I replaced the h with the 8.6. Now use PEMDAS, order of operations. Please excuse my dear Aunt Sally. You're going to look for exponents, 5 squared, right? That means 5 times 5. That's how I got the 25. So on my calculator, I'm just going pi, and I've got the pi key, times 25. That's a times symbol, times the 8.6, and my volume, and I have that squiggly equal sign there. So I'm saying my volume is approximately equal to 675.4, and that line means that 4 repeats, cubic feet, okay? Now, for the sphere, here's my sample sphere problem for you, all right? Here we go. So I drew a sphere. The radius here is 4 inches. Now, the formula for volume of a sphere is 4/3 pi times r cubed. Now, I'm just going to replace my r with this 4 here, so you see my substitution. So I still have the 4 from the formula, times my pi, times my radius 4 to the 3rd power, all that's being divided by 3. And again, you're going to use order of operations. So 4 times 4 times 4, right? That's what 4 cubed means. 4 times 4 times 4, which is 64. So that's what I did there. That's how I got the 64. Now my calculator, I can just go 4 times pi times 64 and get a total and divide the whole thing by 3. So I'm getting a volume that's approximately equal to 268.1 cubic inches. All right, guys, hope that helps. That's everything you need for problem 3A. I'll talk to you in a minute about the next problem. Have a good one.